advanced. In this video, I'll be talking about the Euclidean algorithm. I'm going to explain it and I'm going to give an example for it. Please subscribe. Thank you for watching. So we're going to be talking about the Euclidean algorithm. So the Euclidean algorithm is a fundamental technique in number theory used to find the greatest common divisor called GCD of two integers. So used to find the GCD of two integers. We can call them A and B. The GCD of the two numbers is the largest number that divides both of them without leaving a remainder. So GCD is the largest number that divides both A and B without a remainder, It has been used for centuries. So the principle behind it, the principle behind this algorithm is that the GCD divides A and B, and the difference between the two numbers. And what this translates is to if A is greater than B, then the GCD of A and B is the same as the GCD of something called A mod B. And I'm going to explain what A mod B is. So mod stands for modulo. And the formula for modulo is as follows. let's say that if A is equal to B times Q plus R, where Q is the quotient and R the remainder of the division, then A mod B is equal to the remainder. And we know that the remainder has to be greater than or equal to 0 and less than B for this formula to work. And if A mod B is equal to 0, this implies that this implies that B divides A. No, sorry, we're gonna say it explicit. We're gonna say A is divisible by B. What? So let's give you one example before we go into the example of explaining the algorithm, the Euclidean algorithm. Let me give you an example of A mod B. So let's say A is equal to 10 and B is equal to 3. And we know that A is equal to B times Q plus R. Okay, so first let's divide, let's attempt to divide A, let's do A divided by B. So we do it 10 and then 3 and then so 3 times 3 is 9, remainder 1. So in this case R is equal to 1 and Q is equal to 3. That means that this formula becomes 10 is equal to 3 times 3 plus 1. And as we know that A mod B is equal to R, this implies that A 10 mod 3 is equal to 1 because this is a remainder. So the steps of the Euclidean algorithm. So first we identify, so step one, identify A and B where A is greater than B. Second step, we say A is equal to B times Q plus R. This is called divide and conquer. And remember here, Q is the quotient and R the remainder. Now the third step, which is the repeat step, repeat. So we say that replace A with B, B with R until R is equal to 0. The remainder is equal to 0. So we can summarize as this, repeat A, B until B, R. So the non-zero remainder becomes B. And that's equal to the, and B is equal to the GCV within this algorithm. So now we're going to do one example of the Euclidean algorithm. So find GCD of 48 and 80. And so we say first step one, let A equal to 48 and B equal to 18. And we know that A is greater than B because since 48 is greater than 18. Okay, so now we're going to, so step 2, divide 48 in 18. So that will be 48, 18. Okay, so we say 2. Let's see. 2 times 8, that's 16. Carry 1. 2 times 1, that's 36. 8 minus 6, 2. 4 minus 3, 12. That means that the formula A equal B times Q plus R becomes 48 is equal to 18 times 2 plus 12. Now we do step 3. We're gonna swap step 3. Swap A and B, A and B. Okay, so we're gonna do and B, as we say here, B in with R. A with B and B with R. Okay, so we have 48 equal to 12. No, sorry. 48 is equal to 18 times 2 plus 12. Okay, so now we're gonna swap here. I'm gonna say 18 is equal to, and the remainder R, which is 12 times Q plus R. Okay, now we're gonna repeat. Okay, so 18 divided by 12, that's gonna be 1, 12, 6. Okay, so that will be 18 is equal to 12 times 1 plus 6. So we have 18 is equal to 12 times 1 plus 6. So now we're gonna swap. So 12 is equal to 6 times Q plus R. We're gonna do 12 and 6. So that's gonna be 2. 12, the remainder is 0. Okay, so that will be 12 is equal to 6 times 2 plus 0. Okay, and now we stop because R is equal to 0. That means that, and now we found the GCD. The GCD is equal to 6, our B. So now we say GCD of 48, our initial numbers, 48, 18, is equal to 6. Or we can say we can say, let's say 48 mod AP is equal to 6. So what are some applications of and importance of the Euclidean algorithm? Applications. You can use it to simplify fractions. Cryptography. You can use it to solve Diophantine equations. You can use it for other algorithms, such as for data encryption. That's all I wanted to teach you on this video. Thank you for watching. Please subscribe.